This is a presentation covering California State Water Resources Control Board's Cross-Connection Control Policy Handbook. This presentation is brought to you by the Division of Drinking Water Cross-Connection Control Committee. Before we begin this presentation, here are a few disclaimers. Information provided in this training is intended to educate and assist with understanding the requirements of the Cross-Connection Control Policy Handbook, also noted as CCCPH or Handbook throughout this presentation. Material presented is not intended to be a substitute for the handbook. This training covers the minimum elements of the handbook for public water systems. Not every aspect of the handbook will be presented. For a complete list of requirements, please refer to the latest copy of the handbook. The topics to be covered in this presentation include 1. A brief summary of the background of cross-connection control, 2. The Handbook Cross-Connection Control Program Requirements, which consists of 10 elements, and 3. Developing a Cross-Connection Control Plan, which consists of 13 items and must be submitted to the State Water Board. Here are a few of the commonly used acronyms and definitions used throughout this presentation and in the handbook. CCCPH for Cross-Connection Control Policy Handbook, CCC for Cross-Connection Control, CCCP for Cross-Connection Control Plan, PWS Public Water System, DDW State Water Board Division of Drinking Water, BPA Backflow Prevention Assembly, and LPA Local Primacy Agency. This presentation primarily focuses on describing the requirements listed in the handbook. If you feel you need additional information on topics contained in this presentation, here is a list of other resources available. There is a staff report that accompanies the handbook and provides background into the requirements of the handbook. The staff report is available on the state's handbook website. Other sources listed here include the EPA Cross-Connection Control Manual, which is publicly available for free through the EPA's website. The California Plumbing Code contains plumbing requirements, some of which were carried over into the handbook, and is available through IAPMO. AWWA M14 and USC's 10th edition manual for cross-connection control have a lot of useful information on backflow prevention assemblies and developing a water systems cross-connection control program. On our Cross-Connection Control Policy Handbook website, we will post any updates, latest copy of the handbook, any proposed changes for public review and comment, cross-connection control plan templates for small community water systems and non-community water systems, information for certifying bodies looking for state recognition, and the email backflow@waterboardca.gov to contact us with any general handbook questions. Any questions specific to your water system or review of your plan should be directed to your local DDW district or LPA office. A brief background on the development of the Cross-Connection Control Policy Handbook. Prior to its adoption, the handbook had been in development since 2017. In 2017, Assembly Bill 1671 amended the state's Safe Drinking Water Act, or SWRCB, through the establishment of Health and Safety Code sections shown here, which required that the state adopt standards for backflow protection and cross-connection control through a policy handbook. Assembly Bill 1671 also requires public water systems to implement a cross-connection control program that complies with the handbook. A second Assembly Bill, AB 1180, required the handbook include provisions for swivel oil use at recycled water use sites. The handbook itself went through a stakeholder workshop, 2 public hearings, and 2 subsequent comment periods from 2020 to 2022 before its adoption on December 19, 2023. Here is a brief overview of the handbook policy. The objective of the handbook is to protect the public health through the establishment of standards that are intended to ensure the public water supplies are not contaminated by non-potable liquids or other substances. There are documented cases in the past where illnesses have occurred due to backflow or unwanted substances such as foam or oil backflowing into the distribution systems. In addition, the handbook greatly expands on the previous cross-connection control regulations, which were California Code of Regulations Title 17. These have been repealed in 2024. This training presentation will summarize the differences between Title 17 and the Handbook. In addition, similar to Title 17, the Handbook requires water systems to implement a cross-connection control program. In addition, the Handbook adds certification standards for backflow assemblies, requires certifications for testers and specialists, requirements for backflow incident investigation and reporting, and clarifies the hazard assessment requirement. Here is some general background on cross-connection control. The definition of a cross-connection is any actual or potential connection between potable water from the public water system and water or liquids from outside non-drinkable, non-potable sources. A cross-connection typically consists of a pipe, hose, or tube connected to or has a potential to connect to the non-potable source. These outside non-potable sources can contaminate or pollute the drinking water supply in the distribution system. When there is a cross-connection, backflow can occur in one of two ways, through back siphonage or through back pressure. Back siphonage can occur when pressure is lost in the distribution system, creating vacuum conditions, such as when a hydrant is hit or a water main breaks. In back siphonage, water from a customer's property can go in reverse and enter the distribution system, carrying potential contaminants from that property. To help prevent back siphonage, distribution systems are required to maintain pressure in the distribution system. 20 psi is the required pressure at a water user service connection. Pressure loss that results in pressure below 5 psi requires bacteriological sampling at a minimum. In addition, many water systems maintain a chlorine residual, which can help maintain disinfection in the potable water supply in the event some bacteria enters the distribution system. Back pressure is when used water from a customer's property is pressurized, and if that pressure exceeds the distribution system pressure, the water from that property can be pushed back into the distribution system. This occurs when pumps are used on site, or if the property sits at a higher elevation than the distribution system, such as in high-rise buildings or on hills, or thermal expansion for water heating, creating back pressure. More background on cross connections and backflow. Where are cross connections most commonly found? The plumbing code does a pretty good job of minimizing cross connections by installing built-in backflow protection found on many fixtures such as faucets, sinks, toilets, dishwashers, and other household appliances. However, areas where unprotected cross connections are typically found, according to the EPA, are irrigation systems, fire protection systems, hose bibs and garden hoses, and boilers. Other areas include cross connections with auxiliary water supplies such as swimming pools and spas, private wells, gray water and recycled water systems, and treatment units such as water softeners and RO units. When backflow does occur, the most common contaminants found include heavy metals such as copper and chromium, pesticides such as chlordane and malathion, chemicals such as ethylene glycol, propylene glycol, and freon, detergents, nitrite, and sewage microorganisms such as E. coli and Giardia. Some of these contaminants can cause acute illnesses. Many backflow incidents go unreported or undetected. When a cross-connection exists, backflow protection is needed. This can be done in the form of an air gap, which are commonly built into household fixtures. Air gaps are also needed in industrial applications to provide a physical separation between the potable water supply and industrial processes or wastewater drains. Per the plumbing code, any wastewater or sewer drain must be separated from the potable water supply through an air gap. Air gaps must be inspected regularly as they can be easily bypassed or modified. For when an air gap is not practical, there are several types of backflow prevention assemblies and devices. Assemblies that can provide backflow protection and are installed in the waterline are the Reduced Pressure Principal Assembly, or an RP, Double Check Valve Assembly, or a DC, Pressure Vacuum Breakers, or PVBs, Atmospheric Vacuum Breakers, or AVBs, and Single Check and Dual Check Valves. RPs, DCs, PVBs must be tested annually. RPs can provide protection against health hazard contaminants, back pressure, and back siphonage. DCs can also protect against back pressure and back siphonage, but they can only be used in low hazard situations. PVBs and AVBs are found on irrigation systems and protect against only back siphonage, but not back pressure. Single checks are found in a variety of applications, namely fire sprinkler systems. Dual checks are similar to single checks, but have a second check valve. Both the single checks and dual check valves are not suitable for high hazard environments. AVB's single and dual checks cannot be tested, so these should be inspected or replaced on a regular basis. What is the responsibility of public water systems? The previous regulations, Title 17, and now the Handbook, require water systems to protect the potable water supply through the implementation of a cross-connection control program. Title 17 had required 6 elements in a cross-connection control program, while the Handbook has now 10 required elements, which are presented on the next slide. A cross-connection control program is intended to reduce the risk of contamination of the potable water system by befriending, eliminating, and controlling cross-connections. Per the Handbook, the program must be described and documented in a cross-connection control plan. Here is a brief overview comparing the required cross-connection control program elements in Title 17 and the Handbook. A cross-connection control program consists of the administrative and technical processes a water system must implement. Shown here are the 6 elements previously required under Title 17 and the 10 elements now required under the Handbook. The 6 elements from Title 17 has mostly carried over into the Handbook, but with some significant expansion. In addition, 4 new elements were added, which included tester and specialist certifications, backflow incidents and response, public outreach and education, and local entity coordination. The differences between Title 17 and the Handbook are noted in red. It's also important to note that the Handbook focuses on protection of the water system at the service connections, also referred to as the premise containment protection or meter protection. This is a little bit different from protection requirements within customer premises, such as protection at the taps or point of use, and this is considered internal protection. The staff report and AWWA M14 manual also provide additional descriptions of each of the required elements. Cross-Connection Control Program Element 1, Operating Rules or Ordinances, or also referred to as Legal Authority. The Handbook provides water systems the legal authority to administer its cross-connection control programs. In order to administer the program, water systems need to have a set of operating rules or ordinances to enforce requirements on its customers. This was also a requirement under Title 17. Under the Handbook, water systems also need to include a corrective action to ensure compliance with the Handbook requirements, such as penalties for delinquent testing, installation, and repairs. These corrective actions could consist of discontinuing water service or fines, or the water system could opt to install, inspect, and maintain the backflow assemblies for the customers. Legal authority could come in the form of a municipal code, ordinance, resolution, bylaws, or written agreements between the water system and its customers. If a water system maintains ownership of all the water use facilities within its system, such as government-owned institutions, individual schools, or businesses that also manage its own water supply, then this should be noted on the plan in order to cover the legal authority requirement. Cross-Connection Control Program Element 2, the Program Coordinator. The Handbook provides much more specificity on staffing requirements for administering a cross-connection control program. All water systems must designate a coordinator to ensure that the program is consistently maintained by a designated person. For water systems with 3,000 service connections or more, the coordinator must also be a certified cross-connection control specialist. Water systems with 1,000 to 2,999 service connections need to consult with a specialist on developing the program, writing the plan, and reviewing hazard assessments. Cross-Connection Control Program Element 3, Hazard Assessments. What is a hazard assessment? A hazard assessment is the evaluation of a water user's premises for the potential of backflow and the associated degree of hazard to the public health through the water supply if backflow were to occur. These evaluations were required under Title 17. The intent of a hazard assessment is to identify potential hazards from a water user that could pollute or pose a health risk to the distribution system. Identified hazards need to have adequate backflow protection. Internal protection, or backflow protection within the premises, can be used, but this is generally more difficult to track as a water system jurisdiction ends at the meter. For handbook compliance, backflow protection corresponding to on-site hazards is required at the service connection unless internal protection is used. The hazard assessment requirement also includes residential connections, which were also included under Title 17. The purpose of hazard assessments is to assess the degree of hazard posed by the on-site plumbing of a water user and determine what type or if backflow protection is needed. Training on cross-connection control is needed to identify these hazards. The hazard assessment must consider the items listed in the table here, such as existing cross-connections, materials used on site, likelihood of backflow occurring during back siphonage and back pressure events, piping complexity and modifications, any pressurized systems on site, auxiliary water supply sources, previous cross-connections, or backflow incidents. The handbook also includes inherent characteristics of the distribution system that increase the chances of backflow, accessibility of the user's premises, existing backflow prevention assemblies, and criteria for reassessment. For hazard assessments, some premises have already been identified to be high hazard. Appendix D of the handbook provides an example list of premises that require backflow protection in the form of an RP or air gap. Some of these examples were previously listed in Title 17, Table 1. To identify a premises as a high hazard premises on this list, the water system must have a current hazard assessment documenting the hazards for the user's premises. In addition, some on-site features not classified as high hazard but still require backflow protection include any type of irrigation system, garden hose bibs, on-site treatment system such as small reverse osmosis units and regenerating water softeners, pools, boilers, mop sinks, and soda machines. More examples are included in the references shown back on slide 5. These features typically require some form of internal protection per the plumbing code. Service protection is also required for high-rise buildings and any structures, including residential homes, that are situated at a higher elevation than the distribution system. Requirements for fire protection systems are noted separately in Section 3.2.2 of the Handbook and are required within 10 years of the Handbook effective date, which is July 1, 2034. Low hazard fire protection systems, or ones that do not involve chemical addition, require the minimum protection of a DC or DCDA. High hazard fire systems require an RP or RPDA. In addition, some residential fire systems that meet the criteria listed in Section 3.2.2 of the Handbook can be exempted from DC installation. In the event a backflow prevention assembly, a DC or RP, cannot be installed for a fire protection system, the water system can propose an alternate form of backflow protection and submit this request to the state for review and approval. Water systems can also request an alternative date for compliant with the fire system protection. How are hazard assessments to be conducted? Hazard assessments must be conducted by a certified cross-connection control specialist or by somebody with cross-connection control training and overseen by a certified specialist. A hazard assessment can be done through an on-site inspection. However, on-site accessibility may be problematic for some premises. The handbook notes that the hazard assessment can be done off-site using administrative tools such as customer water use surveys, a review of building or permit records, review of water use activities, and GIS tools. Each method has its benefits and drawbacks. The method of hazard assessment depends on the specialist and water system preferences for its own water system. The chosen method needs to be described in the cross-connection control plan, which will be discussed later. Any hazard assessments that have been conducted in the past can be used for the initial overall hazard assessment as long as the conditions of the water user have not changed. The handbook also requires reassessments to be performed when triggered by certain criteria listed under Section 3.2.1 of the handbook. This includes the changing of account holders, new or reconnecting service connections, changes in water use on the premises, backflow incidents occurring, or if the water system concludes the existing hazard assessment is no longer current. Reassessment is also needed on a periodic basis or upon request by the State Water Board. Cross-Connection Control Program Element 4, Backflow Prevention. Required Program Element 4 covers backflow prevention, which is ensuring that cross-connections are eliminated when possible or controlled by the installation of an approved backflow prevention assembly. This type of backflow protection should correspond with the highest identified degree of hazard at a water user's premises. This table shows the Title 17 requirements compared to the handbook. Title 17 required assemblies pass laboratory and field testing by a recognized testing organization, while the handbook further defines those standards, which includes standards from USC and ASSE. The handbook also stipulates that assemblies cannot be modified after approval. The handbook also provides more specific installation and design requirements, including those for air gaps. Diagrams for backflow prevention assemblies are provided in Appendix C of the handbook. More on backflow prevention. Per the handbook, cross-connections should be eliminated or protected with a backflow prevention assembly. Water systems will need to implement corrective actions on its water users when an unprotected cross-connection has been found, the installed backflow prevention assembly does not correspond to the hazard identified, or the assembly requires maintenance or replacement. Testers do need to notify water systems in a timely manner of assemblies that have failed testing, been modified, removed, or poses a cross-connection risk. The handbook also includes criteria pertaining to swivel Ls in Section 3.2.2d and Appendix C. Backflow prevention with respect to fire sprinkler systems. The handbook specifies requirements for fire sprinkler systems. Water systems are required to ensure its distribution system is protected from fire systems with at least a double check within 10 years of the handbook's effective date, which is July 1, 2034. Fire systems that are considered high hazard, such as those that allow chemical addition, require protection with at least an RP. This requirement also applies to existing fire systems and fire department connections, or FDCs. When a double check or an RP cannot be installed on a fire protection system within 10 years, water systems may propose an alternative date or alternative method of backflow protection. These alternatives must provide the same level of protection. Low-hazard residential fire systems may be exempted from DC installation if the system is considered a flow-through system, where the residence is served by a single service connection for both domestic and fire use. Piping material is considered NSF ANSI 61, and the piping is connected to a fixture to prevent water stagnation. This exemption does not apply to fire systems requiring protection with an RP. Cross-Connection Control Program Element 5, Tester and Specialist Certifications. Tester and Specialist Certifications was added to the handbook as a new requirement. Previously, Title 17 had noted testers and specialists only needed to demonstrate competency, which was generally done through training and/or certification from various organizations with no regulatory oversight. The handbook specifies certain requirements specifically for certifying organizations, which include obtaining State Water Board recognition through an application and review process, obtaining ANSI accreditation by July 1, 2027, training, course, exam, and recertification requirements for both tester and specialist certifications. The state website has a list of certifying organizations posted. Some organizations are working on obtaining State Water Board recognition. Cross-Connection Control Program Element 6, Backflow Prevention Assembly Testing. Assembly testing requirements in Title 17 have been mostly carried over to the Handbook, with a couple of additional requirements. The type of backflow protection must correspond with the degree of hazard identified through the hazard assessment, and this needs to be verified through field inspections. Annual assembly testing is still required, and this now includes inspection of air gaps. Testing is also required after installation, repair, permanent relocation, or repressurization following winter shutdowns. Assemblies that are defective or failing tests must be repaired or replaced within 30 days. Water systems can allow for additional time if this is included in the cross-connection control plan. Those testing the assemblies and inspecting the air gaps must also be certified. Cross-Connection Control Program Element 7, Record Keeping. The Handbook expanded on the record-keeping requirements from Title 17. Each backflow prevention assembly, air gap, and soil well used for Handbook compliance must be recorded along with its assembly type, model, location, recent tests, install date, and any repairs conducted. Records must be kept on file for at least 3 years. The Handbook also requires water systems to maintain records on hazard assessments, associated hazard for each backflow prevention assembly and air gap installation, any recent cross-connection tests, a list of user supervisors, records on backflow incidents, and any materials used for public outreach and education. Water systems can store these records on paper or electronically using a database. Cross-Connection Control Program Element 8, Backflow Incident Response Reporting and Notification. Backflow Incident Response is a new program element that was added to the Handbook. This element requires water systems to investigate, respond, and provide notification to the state when a suspected backflow incident has occurred. Many suspected backflow incident investigations are triggered by customer complaints about their water quality or by an outbreak of illnesses or disease. Water systems must document its response to the investigation, such as recording any samples, water pressure changes, or corrective actions or follow-up activities performed. Water systems are required to notify their DDW or LPA office of any known or suspected backflow incidents within 24 hours of determination. The water system may be requested to provide a backflow incident report. Notification to the state is also needed for coordination efforts between local agencies, public notification, and assistance with any follow-up activities. Cross-Connection Control Program Element 9, Public Education and Outreach. Another new element added to the Handbook is a requirement for public education and outreach. This is intended to educate and inform water staff and customers, as many are unaware of the health risks and impacts from cross-connections and backflow. With more knowledge, the hope is that customers will be more aware and knowledgeable of their plumbing fixtures and water use, reducing the number of cross-connections and thereby reducing the likelihood of backflow incidents. Water systems can conduct public education and outreach through a couple different ways, such as using bill inserts, language in the consumer confidence reports, websites, outreach events, etc. Cross-Connection Control Program Element 10, Local Entity Coordination. Local entity coordination is a necessary component of an effective cross-connection control program. Installation and/or modification of backflow prevention assemblies, such as those in new construction or redevelopment projects, often involve plumbing code officials such as building and safety or permitting departments. Oftentimes, these officials or departments are informed first about the new water users and plans that are assessed for hazards and backflow protection. Backflow protection assemblies found on fire protection systems often require coordination with the local fire department or fire marshal. Internal backflow protection, such as those found in restaurants, hospitals, and other commercial establishments, may be under the purview of local county health departments. Coordination between local entities and water systems is also necessary when a backflow incident occurs. Cross-connection control plans. A new requirement with the Cross-Connection Control Policy Handbook is the development of a cross-connection control plan. The plan is due 1 year after the Handbook's effective date, which is July 1, 2025. Water systems can request an extension if more time is needed to develop the plan. Public water systems are required to implement a cross-connection control program in accordance with the requirements in the Handbook. The cross-connection control plan is one of those requirements and serves as a document description of a water system's cross-connection control program. A water system can implement its plan before receiving plan approval from the state. If a water system needs a special or expedited review of its plan, they should coordinate this with their district or LPA office. In general, each water system is different, and the plan should be written to reflect these differences within each water system. Here is a summary of what is required in the cross-connection control program and what items are needed in the plan. The program must consist of these 10 elements, while the plan requires a written description of how these 13 items are implemented in the program. Cross-connection control plan item 1, the compliance statement. The compliance statement is a description of how the water system will achieve and maintain compliance with requirements in Chapter 3 of the Handbook. This can be a basic statement such as, the water system will protect its potable water supply through the implementation of its cross-connection control program described in this plan, or something similar. Cross-connection control plan item 2, hazard assessments. The water system must describe its process used for conducting hazard assessments. A hazard assessment can be done through an on-site inspection or using administrative tools such as customer water use surveys, review of permit records, review of water use activities, and GIS tools. Each method has its benefits and drawbacks. The method of hazard assessment depends on the type of premise being assessed, specialist, and water system preferences. The water system also needs to note who will be conducting the hazard assessments. Options include the water system's certified specialist, or trained staff being overseen by the certified specialist, or an outside contractor with a specialist certification. For community water system hazard assessments, the timeframe for completing the initial hazard assessment needs to be included in the plan. Water systems must propose this timeframe and should include how many assessments are expected to be completed each year to explain the timeframe. For larger water systems, the timeframe can be broken into separate categories based on its service area or potential hazards, such as a timeframe for industrial users, commercial users, and/or residential users. It is recommended that the water systems prioritize higher risk water users. Water systems should also note when periodic hazard assessments are to be conducted and specify the conditions or triggers for reassessing a premises. Cross-connection control plan item 3, legal authority. Legal authority was described in our handbook presentation covering the background and program elements. For the cross-connection control plan, water systems are required to provide a copy of its legal authority needed to administer its cross-connection control program. The legal authority could come in the form of a municipal code, ordinance, resolution, operating rules, contractual agreement for water service, etc. The legal authority should have an adoption or effective date. If it has not yet been adopted by the Water Systems Governing Board, a timeframe for anticipated adoption needs to be included in the plan. If legal authority is not needed because the water system already has or taken on the responsibility of implementing its own backflow protection measures, then this should be noted in the plan. For example, this can occur in commercial or institutional facilities that maintain its own water system. Cross-connection control plan item 4, backflow prevention assembly, inspection and testing. For this plan item, describe the process and timeframes for ensuring each backflow prevention assembly is inspected and field tested, and each air gap used for the handbook compliance is inspected annually. Water systems are also required to ensure that backflow prevention assemblies are installed when required, installed correctly, not modified, damaged, or vandalized, or removed, etc. In the plan, the water system needs to note who is responsible for the inspections and field testing. Testing and inspection can be contracted by the customer, contracted or performed directly by the water system, or both. The plan needs to include the time frame for testing. Annual testing is the most common, but water systems can propose more frequent testing. The time frame should include adequate time for repair and/or follow-up to meet the state requirement of having all assemblies tested each calendar year. Cross-connection control plan item 5, non-testable devices. This plan item refers to internal backflow protection at a water system's own facilities, such as treatment plants, booster pump stations, well sites, tanks and reservoirs, etc. Water systems are required to describe the process and timeframe for inspecting and maintaining backflow protection devices found within its facilities. This includes any vacuum breakers, check valves, air gaps, hose bibs, etc. One way to address this plan item is to have a cross-connection control survey conducted at each of its facilities on a regular basis. Internal backflow protection needs to comply with the California Plumbing Code. Non-testable devices typically need to be replaced every couple of years to ensure that they are working correctly. Cross-connection control plan item 6, tester qualifications. Water systems are required to confirm testers used are certified using field test equipment that has been verified for accuracy and submitting completed test reports. In the plan, water systems must describe the process used to verify its testers. For larger water systems, one example is the use of an approved tester list, in which testers are required to apply annually for a pre-approved tester list and submit field test equipment verification paperwork. This list could be maintained by an outside entity or by the water system itself. Another example is that water systems could verify testers as test reports are being submitted. Water systems also need to note what information is being reported to the water system. This can be achieved by including a copy of the test report in the plan. Water systems should also include a quality assurance protocol to verify testers are completing test forms correctly. Water systems can have a spot check program in place to identify any problematic or questionable testers. Example of problematic testing would be falsified testing records or drive-by testing. Any testers found to be negligent should be reported to the certifying organization for investigation and corrective actions. Cross-connection control plan item 7, backflow incidents. Water systems are required to develop and implement procedures for investigating and responding to suspected or actual backflow incidents. For the plan, the water system must include a description of how it will respond to backflow incidents. Backflow incident response must include DDW or LPA notification, impacted customer notification, identification of the backflow substance, or operational response to the incident, such as isolation of the area within the distribution system and subsequent corrective actions, customer complaint documentation, and any other related actions and follow-up activities. Backflow incidents response should be coordinated with a certified cross-connection control specialist and the local DDW LPA office. If directed by the State Water Board, the water system may be required to issue a Tier 1 public notification. The Handbook contains an example backflow incident response form and Appendix F, which may be used in reporting the incident to the State Water Board. Cross-Connection Control Plan Item 8, Contact Information. This plan item is pretty straightforward. The plan must include contact information for the Cross-Connection Control Coordinator and/or specialist and any other persons involved with the Cross-Connection Control Program. Cross-Connection Control Plan Item 9, Tracking System and Record Keeping. For this item, water systems are required to describe its system used to track hazard assessments, backflow prevention assemblies, and air gaps used for handbook compliance, the location, type, and testing of these assemblies, and fire system backflow protection. Water systems can use any system it finds suitable for its service area. This information should be readily available upon request by the State Water Board or for public or customer inquiries. For non-community water systems, the tracking and record-keeping requirement is similar to community systems. In addition to any service connection backflow protection, non-community systems must also track backflow prevention assemblies and other devices used for internal protection, as well as the associated hazard for each device. This includes an inventory of any air gaps, single checks, dual checks, atmospheric vacuum breakers, hose bib vacuum breakers, anti-siphon devices, etc. The template provided on the state website includes an attachment page for inventorying these items. Cross-Connection Control Plan Item 10, User Supervisors. For this plan item, if a water system has any service connections that requires a user supervisor, a list of user supervisors will need to be included in the plan. In addition, any training requirements and contact information for the user supervisors also needs to be included in the plan. User supervisors are needed when a premises has recycled water or an intricate complex distribution system, such as industrial or other non-potable water lines. Examples can include large water use sites such as industrial facilities, wastewater treatment plants, airports, university campuses, hospitals, or institutional facilities. Cross-Connection Control Plan Item 11, Corrective Actions. The water systems must describe the process on how it will enforce compliance with handbook requirements, such as testing, inspections, repairs, replacement, or installation of a backflow prevention assembly or air gap. This should be included in the water system's legal authority document. The water system needs to describe how it will implement the corrective action. This may include the use of warning letters, fines, or service disconnection. A timeframe for corrective actions, for example 30 days, also needs to be noted. Cross-Connection Control Plan Item 12, Public Outreach. This item is fairly straightforward. The water system must include a description of how it will conduct public outreach and education to engage its customers on cross-connection control. This could be done through the use of an informational website, bill inserts, outreach events, or etc. Cross-Connection Control Plan Item 13, Local Entity Coordination. For local entity coordination, water systems need to include its procedures for coordinating or engaging with other agencies involved with backflow protection and cross-connection control. These can include local health departments, fire departments, building permit departments for new building construction or building use changes, or any other water agencies connected to the water system. This concludes the overview for developing a cross-connection control plan. To comply with the plan requirement of the handbook, plans need to be submitted to the local district or LPA office by the deadline. Also, the plan must be current and representative of the water system's cross-connection control program. If there are any substantive changes to the program, the water system is required to submit a revised plan. For any general cross-connection control policy handbook questions, you can email backflow@waterboards.ca.gov. Questions that are specific to your water system or your plan, please contact your local DDW district or LPA office. This concludes the presentation. If you have any general questions related to the Cross-Connection Control Policy Handbook, you can email the State Cross-Connection Control Committee at backflow@waterboards.ca.gov. For questions specific to your water system, please contact your local DDW district or LPA office. Thank you for your time.